everybody's doing well. This is going to be our first virtual lesson. What we're going to do today is we're going to go over Hess's law. And it's another way to calculate enthalpy, which is delta H. What I'd like you to do is, on the PowerPoint that you have from chapter 5, you're going to notice the example 5.9, there's a sample problem on Hess's law. Now what we're going to do is let's go over the ground rules and let's go over what you're allowed to do. Our ultimate goal is to find the delta H of what I call the net equation, which is this one up here. If you follow along in the PowerPoint 5.9, you're going to see that you are given three equations. But what we're going to do is we're going to manipulate these three equations to find the net equation. So here's the objective and the rules of what you can do. Behind me, I rewrote the problems. So I'm calling the first equation number 1, then number 2, and number 3, and then the one up here, which is the one I wrote down here. This is our net equation. This is the one we're trying to find. Now, what you're allowed to do is you can manipulate these three, but you cannot touch this one. This is the one that you're trying to get. The first thing you're allowed to do, and if you remember we studied this with equilibrium, is you can flip an equation. What I mean by flipping an equation is if you flip this, the reactants become the products and the products become the reactants. Okay? So you're switching the equation. Now here's the catch. If you flip the equation, you also have to flip the value of delta H. Okay, these three that you see on the board, they're all negative. That means they're all exothermic. So if I flip an equation, then in this case, it would go from negative to positive, okay, or vice versa. So that's the rule, the first rule. If you flip an equation, you must change the sign of the delta H. Next rule, sometimes we need to multiply an equation by a factor. Let's say I needed to multiply this by 2. If I multiply the equation by 2, I also have to multiply the delta H value by 2. In other words, whatever you do to the equation, you also have to do to the delta H. Okay? When I'm done with this lesson, I'm going to compare how to how to use Hess's law in thermodynamics versus how you used it in equilibrium, so you can see the similarities and the differences. So, one last rule. If you divide something by 2, or let's say you're multiplying by a half, which would be the same thing as dividing by 2, again, if I divided this by 2, I would have to divide the delta H by 2. So the theme here is whatever you do to the reactants, you must also do to the products. Okay? Excuse me. All right, so let's take this one so we can start. If you look at this problem, I usually go in order. There are 3 carbons in the net equation, so look for which equation has carbon. The second equation is the only one that has carbon. Now, there's supposed to be 3, and yet that one only shows 1. So here's what we're going to do. We're going to get that equation, and we're going to multiply the entire equation by 3. Now, again, whatever you do to the equation, you have to do to the delta H. So, if you use your calculator, if you get negative 393.5, we're going to need to multiply that by 3 as well. So if you multiply this by 3, you're going to get a delta H value of negative 1180.5 kilojoules. Okay? So that's the manipulation of the first equation. All right, let's go to the next one. The next equation is hydrogen. As I look, the hydrogen here is in the first one. Okay, I'm sorry, equation number 3. And it's in the reactant side where it's supposed to be, but there should be 4, there's only 2. So what we're going to do is we're going to get equation number 2, and we're going to multiply it by 2. And I'm going to rewrite it. So this becomes 4H2. You're going to multiply everything by 2. Okay, so you put that there. Multiply this becomes 4 waters. And the most important part is, since we multiplied by 2, let's get this number, negative 483.6. Okay? let's multiply that by 2, and we're going to get negative 967.2 kilojoules. So this equation got manipulated. So far we're doing pretty good. We only got one more, okay? Now, notice equation number 1 has this one. It's the correct amount. There should be 1, but it's on the wrong side. So here's where flipping comes in. We're going to flip equation number 1. So the products of number 1 are going to become the reactants. So here's this over here. Then you put this one over here. Now we're going to put the reactants over as products. And in this case, when you flip, all you got to do is flip the sign, so it's going to become positive 2,043 kilojoules. Okay? So here's what I'm going to do. To avoid clutter, I'm going to erase the 2 equations that I manipulated and leave on the board the ones we need. So I'm going to erase this one, which we multiplied by 2, and we flip this one over here and change the sign. Okay, so here's what we got. The nice thing about Hess's law, we're going to combine the 3 equations. If you see something on the left and on the right side, okay, they're opposite sides, they cancel. So there's some things that are not down here because they're going to end up canceling each other. Let me give you an example. 4 waters on the right side and 4 waters on the left. That's why they don't appear down here. 3 carbon dioxides here and 3 over here. Again, that's why they don't appear down here. The only ones that are down here are the ones that don't get canceled. For instance, you're going to see this one appears over here. Then this one appears over here. Now look at this interesting part with oxygen. There's 5 on the right and 2 on the left. So 2 of these will cancel 2 of these, leaving you with 3 left over. Okay? And actually, let me see. I apologize. There's 2 here and 3 here. There's 5 here. And there's a 5 here. Didn't see that one. So those 5, you add them up because they're on the same side. And there's 5 on this side. So combining these 2, these 5 and these 5, you have 5 on each side. And that is why they don't appear down here, because they cancel. Okay? And the only guy left is this guy over here. Now, how do you find the answer? Well, these are the new values after we manipulated the equations. To find delta H using Hess's law, what you do is you add the delta H's of the individual equations of 1, 2, and 3. So we're going to get 2,043 plus negative 1180.5 plus negative 967.2. We're going to go ahead and add that up. So let's see here, 2,043 plus negative 1180.5 plus negative 967.2, and we're going to get 104.7 as kilojoules as the delta H. Now this one is on the PowerPoint. If you can see on the whiteboard, this one's worked out. They go over the steps, so you could do that if you need to at home. Okay? And they rounded it to negative 105, which is fine. Okay? You can leave it at negative 104.7, but there is your answer. Okay? And that would be the answer to this first problem. Okay? All right. So I got a couple more practice ones here that I'd like to do with you. All right? I'll do these, and then I'll tell you the assignment afterwards. So let me erase this here. The first one is worked out for you, so you guys have that one. And we have a new problem here that also has 3 equations. Okay, so the first one, and what I'll do is I'll rewrite them over here so we don't have to do it again. The one we're trying to find is N2O gas plus NO2 gas, giving you 3NO gas. This is the one we're looking for, the delta H. Now, if you notice, let's manipulate these. So who has N2O? The bottom one has N2O. It's the only one that has N2O. So what I'm going to do is, notice they're not correct. This one has 2, but it should be 1. What we're going to do is we're going to multiply the third equation by a half. So if you multiply, and I'll do this is the third equation. If you multiply it by a half, okay, this is what we're doing. You get N2O gas. You multiply the other 2 by a half, and you're going to have fractions, and that's normal. But this one, half of 2 is 1, so you get N2. And then the oxygen will be a half. Okay? So you're multiplying the third equation by a half. Okay? So don't forget, we got to multiply the delta H by a half as well. So let's get that number. Negative 163.2 divided by 2 is negative 81.6 kilojoules. So we're good there. Okay? All right, let's continue. NO2. The only guy I see that has NO2 is the first equation. Now, look at this. Not only is it in the wrong place, we're going to have to flip this, but we're also going to have to divide that by 2. So, and you're allowed to do that. You're allowed to do 2 things. We're going to get equation number 1, and we're going to flip and multiply by a half or divide by 2. So I'll do it simultaneously. So this will become NO2. Okay? And then the new products, divide 2NO by 2, you get that. And the oxygen will also be half an oxygen. So we got to do 2 things here. We got to change the sign, so it's going to be positive, and divide the 113.1. Divide that by 2, and you get 56.55 kilojoules. Okay? Now, let's go to the final one here, NO. This one has NO. Now, this one's a little bit tricky. Let's take a look here. All right, here we're going to have to think a little. Notice that N2 doesn't appear here at all. I don't think, right now, if you leave equation number 2 alone, and sometimes you need to do this, you need to anticipate by looking at the bottom. If I leave that alone, notice that these 2 are perfect. They'll cancel each other out because they don't appear down here. We might be done, okay? We might be done here, so what I'm going to do is I'm going to start putting this together, and I know these 2 will cancel. That's for sure, okay? Now let's see if there's anybody else that cancels. Notice oxygen doesn't appear. Look at this. This half and this half are on the same side. That's 1 oxygen if you put them together. This 1 oxygen will cancel that 1 oxygen over there, and that's the reason you don't see oxygen down here. This guy is perfect, okay? In fact, this one is perfect too. Now, look at this. There's 2 NOs here and another one here, and they're on the same side. Add them up when they're on the same side. Subtract when they're on opposite sides. So when you add this, you get the answer. Okay, now I forgot to write the value here. We didn't do anything to this one. This one's 182.6 kilojoules. So how do you find the one we want? Add them up. That is how Hess law works. So we go 56.55, okay, plus 182.6 plus negative 81.6, we get 157.55 kilojoules, and that is our delta H for this reaction. Okay, let me see if the answer to these are not on the PowerPoint, so we'll do them together. Okay, we got one more we're going to do here, and then I'm going to take you to the packet, the first packet that I gave you on thermodynamics. All right? Hopefully you're catching on to this. By the time we're done, we'll be done with at least 4 problems. So what we're going to do is, down here, there's a problem that says, for more practice, 5.9. And what we're going to do is, I'll do the same as last time. I'll write the net equation. So this is the one we're trying to find. Okay, so here we go. This one only has 2 equations. They don't always have 3. So we're trying to find the delta H for this equation here. And if you look here, this is the one we want. We got these 2 to manipulate. So let's go through this. All right. According to this one's a little bit tricky. You need 3 of these, and there's 2. You're sometimes going to need to use fractions, okay? You're not used to using fractions in equations, but with Hess's law, that actually is very normal. So what we should do here is, there's a 2 here. We want to get it to a 3, okay? So let me write this down here. This is the one we're going to manipulate. This is number 1. I'll write it down. Okay, so our goal is to get this to 3. So if you multiply by 3 over 2, okay, then this is the math. 3 over 2 times 2 gives you 3, okay? So what we're going to do is we're going to multiply this whole thing by 3 over 2. So when you multiply that by that does give you this. Okay, this is fine. This is 3 over 2 oxygens. And by the way, 3 over 2 is 1.5. Okay, so keep that in mind if you don't like fractions. This one, the same thing. This one's going to be 3 waters. And then down here, let's get the delta H for that first reaction, and let's multiply it by 3 over 2. So you got negative 483.6 times 3 divided by 2, and you get negative 725.4 kilojoules. Okay? And then we got one more. All right? So this one we already manipulated. So ozone. Notice ozone should be on the left. This one's on the right. We're going to definitely flip that. Okay? In fact, I'll flip it right now. We're going to flip this. Okay? But the number's not correct. According to this, there should be 1. So for this one, we need to flip and multiply by a half. You multiply that by a half, okay? You get 1 ozone, and then this is the tricky one. You get 3 over 2 oxygens. 3 multiplied by a half is 3 over 2, okay? And the delta H for this one, now remember we got to first change the sign, so it's going to become negative 285.4, and we need to divide that number up by 2, and you get negative 142.7 kilojoules. Okay? So, at this point, let's check. I don't think there's anything else to do. And let's see if everything matches up. I know this matches up, and I know this matches up. Now, look at the oxygens. Notice they don't appear here. This is perfect. 3 over 2, or 1.5 on this side, 1.5 on this side. We're good to go. And then this one over here. So this one ends up being a pretty simple one. So it's negative 725.4 plus negative 142.7, and we get negative 868.1 kilojoules. This one's exothermic. Okay, and that is our third Hess law problem. Okay, so far so good. Now, the last one we're going to do is, I gave you guys a packet, and at the bottom of page 238 on the packet, right over here, you'll see in bold, it talks about what Hess's law is, and it goes over the a tutorial as far as the rules, okay? And as I scroll down here, you'll notice that there's a sample one. I'm not going to do this one with you, but they want to find this one using these two. They give you here the steps, okay, whether you have to flip something, multiply by a factor, divide by a factor. The steps of that one are explained in the tutorial, okay? And then it shows you here another example, okay? And I'm going to let you guys look at this. This one, you're looking for this one. You're given these two. Again, the steps are shown here, okay? So follow along with that one. That's going to be on you. And we have one final one that I'll do with you. And it's this practice problem, and it's on page 239 is it 239? Let me check here. This is from the packet, the 240. It's going to be the on page 240. This will be our one more that we can work with. Let me zoom in here so you guys can see it a little bit better. Okay, so if you have the packet handy, just follow along with me. And this will be our last one for today. So here's what we got. We have, this one has 3 equations, and you are looking for the delta H of the net. Let me write that one down. So it's 2HCl gas plus F2 gas yields 2HF liquid plus Cl2 gas. And we're going to look for the delta H of this reaction, the net. I always call it the net. Okay, so let's take a look at this. Who has HCl? The first one does. However, it's not correct. Should be 2. There's 4. Let's get that first equation. Let's cut it in half. So we're going to divide that first equation by 2. So we no longer have 4 HCl's. We got 2 HCl's. We have half an oxygen gas. Okay? And then we got here 1 water, since we're dividing by 2, and 1 chlorine. Okay? Again, whenever you divide, whatever you do, you got to do it to the delta H. So it's negative 202.4 divided by 2, and you get a delta H of negative 101.2 kilojoules. Okay? Now, let's keep going. Who has fluorine? Well, this one has fluorine. Now notice 2 things. It's on the wrong side. We're going to have to flip this. And there's half there. It should be 1. So we're going to flip and we're going to multiply by 2. Okay? Because we've got to do both in this case. So I'm going to do this simultaneously. If I multiply this by 2, these become 1 each. I'm going to put them on the left because I'm flipping it. So you now have 1 hydrogen here. And you have 1 fluorine here, which is what we wanted. And we have 2 HFs over here. So we got to change the sign of this, okay? So it's going to be negative 299.8. And we multiplied that by 2. So we have a delta H of negative 599.6 kilojoules. So we change the sign and multiply by 2. All right? Okay, HF. Well, right now, when we flip this and multiplied by 2, we actually took care of this. So we're good so far there, okay? And then chlorine, right now, chlorine looks good as well, okay? And you know, I apologize, this is equation number 3. Not that it matters, but I'm looking, we only have one thing left. And the only one left is that middle one. Now, I'm noticing something. Notice the middle one has hydrogen, and we had flipped the hydrogen over here. Hydrogen does not appear here. What I'm trying to say basically is I think those hydrogens are going to cancel if we leave equation number 2 alone. I'm going to show you what I mean. If we leave this equation, oops, that's the yield sign. If we leave this equation here, as is, And sometimes you don't have to do anything to an equation, okay? Sometimes you gotta do two things, like flip something and multiply by a factor, which is what we did in number 3. But equation number 2, from what I see, I don't think we need to do anything to it. Okay? So, let's take a look here. From what I'm looking at, I see that these two are on opposite sides, and that's why I wanted you to leave it alone, because it doesn't appear down here. Now watch what's gonna happen. You know this guy that comes down here. The waters don't appear here because they also cancel, they're on opposite sides. There's that fluorine that we fixed, and then oxygen doesn't appear because that half on that side and that half on this side get rid of each other. This one doesn't get canceled, this one doesn't get canceled, and it looks like all we have to do now is add these 3 numbers. Okay, so let's see. I'm going to add the 3, and I got -415 kilojoules. Now this one is, the packet does give you the answer here and the explanation, and we did indeed get the correct answer. Okay, so basically these are, you know, the steps that you're allowed to use. Now, before I close out today, look at the difference between doing Hess's law thermodynamically versus equilibrium. Let's talk about what happens when you flip an equation. In thermodynamics, when I flip an equation, I flip the sign. Okay? When it was equilibrium, instead of it being delta H, it was a K value. And what you did was, you didn't change the sign. If the value was, let's say, 20, okay, what you did is you got the inverse. It was 1/20. So you get the reciprocal when it's equilibrium, when you flip an equation. But in thermodynamics, which is what we're doing now, you just change the sign. So there's a difference there. Here's the second difference. If you multiply something by 2, you multiply the delta H by 2, okay? In equilibrium, when you multiplied an equation, all right, you had to, let's say I multiplied by 2, you would have to square the K value. Okay, if you multiplied by 3, you would cube the K value. Here, you multiply, and you multiply the delta H. This one's a lot more simplistic, all right? If you were dividing, okay, like today, if I divided by 2, like we did with the first one, you divide the delta H by 2. When it is equilibrium, if you divide by 2, you have to get the square root of the K value. If you divide it by 3, you get the cube root. And finally, once you have all your delta H's in thermodynamics, you simply add them to get an answer. In equilibrium, let's say you have K1, K2, K3, you don't add them, you multiply them together. That's a huge difference, okay? So I'll repeat that. For thermodynamics, you add the delta H values. In equilibrium, you would multiply the delta H values. So I just showed you how to use Hess's law to find delta H. In the future, we're going to be learning about something called delta G, which is Gibbs free energy. And there's going to be a session where delta G can also be found using the same technique, Hess's law. Okay, so I hope I was able to explain this. We at least got 4 problems in the books. Okay, thank you very much.